this video, we're asked to find the value of x and y, and we want to be careful that x is not equal to y. In x squared minus y equal to 133, and y squared minus x equal to 133. How do we solve this Math Olympiad exam question? Join me as we find an answer to this. But before that, don't forget to like, subscribe, and also turn on the notification bell in order to get our subsequent videos. Let's get started. We are going to consider this first equation to be equation 1, and then we'll consider this to be equation 2. So what we are going to do simply is to subtract equation 1 from equation 2 from equation 1. So we're going to subtract equation 1, equation 2 from equation 1. So if we subtract equation 2 from equation 1, we're going to have 2 first, and that will give us x squared minus y, right? And this will be minus y squared minus x, and this will be equal to 133 minus 133. So if we simplify that, we're going to have that expression to now give us x squared minus y squared minus or plus x, because minus times minus is plus, and that will be equal to 0. So if we do this, we are going to collect the squares, and this will give us x squared minus y squared minus y plus x equal to 0. And if we rearrange this, we're going to have this to become x squared minus y squared plus x minus y, and this will be equal to 0. Now recognize the fact that this is a perfect square. If this is a perfect square, then that is going to give us x plus y multiplied by x minus y, and this can be plus x minus y, and this will be equal to 0. Because if you expand this, we're going to still have what? This. Now if you come to see, you see that x minus 1 y is common, so we're going to bring out the common term x minus y, and if we bring that common term, all of these divided by x minus y is going to give us x plus y, plus all of these divided by x minus y is going to give us 1, and all of these will be equal to 0, and this is more of the zero product law. So we're going to have the first case to give us x minus y to be equal to 0, and then we'll have the second case to give us x plus y plus 1 to be equal to 0. So from here, we'll come to see that x is equal to y. And remember that the solution says x must not be equal to y. So in this regard, this will not be a solution because x is not equal to y. So from this part, we're going to see that x, from this equation, we're now going to see that x plus y can be equal to -1. So we're going to take this as equation 3. We'll asterisk this as equation 3. Now let's go back to the main equation we have. From the first equation, we subtracted equation 2 from equation 1. So this time around, we're going to add equation 2 to equation 1. Now let's add equation 2 and equation what? We're going to add equation 2 That is equation 1 plus equation 2. Now, if we add those two equations, what are we going to arrive at? We're going to now have x squared minus y. That will give us x squared minus y, right? Plus y squared minus x, that's what we'll have there, equal to 133 plus 133. And then this is going to give us x squared minus y minus or plus y squared minus x equal to, this is going to give us 266. Now let's arrange the equation properly. If we arrange this equation, we're going to have the two squares coming as one y squared, right? And this is going to give us negative x minus y, and this is equal to 266. Great. Now remember that this can also be a perfect square. Now let's take this over to the other way. If we take these two equations over the other way, we are going to have x squared plus y squared to be equal to 266 plus x plus y. Now what do we have from equation 3? X plus y is equal to minus 1. So that expression will now give us x squared plus y squared will be equal to 266 plus minus 1. So plus times minus is going to give us 266 minus 1, and then our x squared plus y squared will now be equal to 266 minus 1, and that means our x squared plus y squared will be equal to 265. So we are going to consider this to be equation 4. Great. Now from equation 3, you come to see that x plus y is equal to negative 1. So let's consider equation 3. From equation 3, we saw that x plus y is equal to negative 1. So what do we do with this equation? Equation 3, we're going to see that from this equation 3, if we look at the value x plus y all squared, if we square both sides, we're going to have negative 1 or what? Square. Now from this algebraic expression, if we expand this, this is going to give us x squared plus 2xy plus y squared, and this will be equal to 1, right? So if we bring the x as common term, x squared plus y squared plus 2xy, this will be equal to 1. So from here, remember x squared plus y squared from equation 4, x squared plus y squared is equal to 256. So we are going to replace that with 2y6. So this will be what? 256, because x squared plus y squared according to equation 4 is 265. So this is going to give us 265 plus 2xy, and that will be equal to 1. So 2xy will be equal to 1 minus 265. and that will give us x 2x y to be equal to negative 2 6 4. We divide here by 2 and divide here by 2. This is going to give us xy will be equal to 2 divided by 2 is 1. We'll have negative 1. This will give us 3 and this will give us 2. So xy is negative 1 2 5 and to 1 3 5, 2, and we'll take this as equation 5. Now we have 5 different equations. Now the question is, how do we find the value of x and y from all these equations we have just derived? Now let's go back to one algebraic formula. From that algebraic formula, we can be able to make a headway. From that algebraic formula, I want you to recall that if you have a minus b all squared, this can be equal to a square plus b square minus 2ab. Now let's assume we have x minus y all squared. In this regard, we are going to consider this to be equal to x squared plus y squared minus 2xy. Now from this expression, you can see now that we already know the value of x squared plus y squared. Recall equation 4, right? And that is 265 minus, we already know the value of xy, that is 2 multiplied by negative 132. That's equation 5. So if we simplify this, we are simply going to have this expression to give us 265 plus this times 1 will give us 2, this times this will give us 6, and then what? 4, because minus times minus will give us 4, right? Will give us plus. So that means our x minus y all squared can be equal to this. So we can simply put our x minus y all squared to be equal to the sum of these, which is 5 to 9. We can find the value of x minus y if we take the square root of both sides. Now let's take the square root of both sides. If we take the square root of both sides, this will give us square root positive negative. While this destroys the square root, we are going to have x minus y to be equal to plus or minus square root of 526 is 23. So we see that the value of minus x minus y is plus or minus 23. Now let's look at this expression, x minus y equal to plus 23. That's the first equation. And we can see that x from our initial expression, remember equation 3, we found earlier on. From equation 3, we found out that our x plus y is equal to negative 1. So if x minus y is equal to 23 and x plus y is equal to negative 1, we take it as equation 2. If we solve these two equations, we should be able to find the value of x and y. On the other hand, if x minus y is equal to negative 23, and we are given the other equation, x plus 1 to be equal to negative 1, we're going to solve this and also compare the two solutions. Now let's solve this. To solve this using the elimination method, we're going to subtract equation 2 from equation 1. Using the elimination method, we can add to eliminate y and what? And y. So this is going to give us 2x, while this gives us 0, equal to 23 plus minus 1 is going to give us 22. So if we divide here by x by 2 and divide here by 2, we're going to have our x to be equal to 22 divided by 2 is going to give us 11. So our x is equal to 11. So if x is equal to 11, let's consider equation 2, given that x plus y is equal to minus 1. So if x is equal to 11, we'll have 11 plus y to be equal to negative 1. So y will be equal to negative 1 minus 11. And then our y will be equal to negative 12. And that is the value of our y. So from this expression, we have seen that x is equal to 11, y x comma y is equal to 11 comma negative 12. Now from this other solution, what can we find? From this other solution, we are going to consider these two solutions, and if we add these two solutions, if this is x plus y, if we add this, this is going to give us 0, and then we'll have 2x equal to negative 24, right? So divide here by 2 and divide here by 2, x will be equal to negative what? 12. So if x is equal to negative 12, given equation 2 that x plus y is equal to negative 1, then negative 12 plus y will be equal to negative 1. If we find the value of y by adding 12 to both sides, we'll have y to be negative 1 plus 12, and then our y will be equal to 11. So from this other side, we can see that if our x comma y is equal to x is negative 12, while our y is positive 11. So these are the solution that satisfies that equation that is given to us up there. In the first expression, x is equal to 11 and y is negative 12, yx is negative 12 and y is 11 in the second solution. Now let's check to see if our solution is absolutely correct. Now to check, we're going to use this expression. Let's check using the value of x comma y to be equal to 11 comma minus 12. Using the first expression given to us, we have our y square, our x square plus, from the first expression given to us in the initial equation, x square minus y equal to 133. So if we are given x square minus y equal to 133, if we take the value of x square minus y, x square minus y, will it be able to give us 133? Now let's check out. X square is 11, so we'll have 11 square minus negative 12. Will this give us 133? Let's find out. 11 square is going to give us 121. Minus times minus is going to give us plus 12, and this will be equal to 121 plus 12 is going to give us 133. So you see 133 is equal to 133. So 121 plus 12 is equal to 133, and that is going to give us 133. So 133 is equal to 133, which tells us that the solution xy equal to 11 and minus 12 is absolutely right. So you can try this for the other two solutions, and you find out that the solution we have for the set of equations given to us above are absolutely right. If you do enjoy this solution, don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.